Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel. And it also helps us reach others in need of assistance with these topics. So what we're going to be covering today is we're going to be doing structural analysis, and we are going to be finding beam reactions for statically determinate beam members. And this will be the second part in our series. So we will be finding the reactions for this beam shown on the screen here. So a few things that you want to note out is that this is a pin over here. And this is a roller right here. Pretty much anytime you have that little circle, it's just a little bit of a roller. So remember that a pin will have the ability to have reactions in both X and Y directions, pretty much any direction except for a rotation. And then the roller will only have one reaction in one direction, and that direction being perpendicular to the surface it is resting on. So what I'm going to have here is I'm going to assume my reaction of BY in the upward direction, and I'm going to assume my AY in the upward direction. And since it is a pin, it will also have a possible AX, which I'm going to assume that to the left. Remember, when you're finding beam reactions, just throw on your assumption errors because it does not really matter which way they're going. If you get a negative answer in the end for your reaction, that just means you assume the wrong direction. So drop the minus sign and flip the arrow. If you get a positive answer, that means you assumed correctly. Alrighty, so typically with beams, what you're going to do is you're going to use your equilibrium equations of summing forces in the X equal to 0, summing forces in the Y equal to 0, and summing moments about a point equal to 0. And we know that we can use these equilibrium equations if the beam is statically determinate, meaning that we only have three reactions, which we do. A sub X, A sub Y, and B sub Y. Three unknowns, utilizing three equations to find them. Alrighty, so typically we would start with summing moments, but let's start with the easier version, or the easier portion here is just finding what A sub X is. So I'm going to sum forces in the X direction equal to 0, and I have A sub X assumed to the left, so it's minus A sub X. And then I have this 50 kips, which is going to have a portion vertically and acting to the right because it is coming down and to the right. So it'll be down in the vertical, right in the horizontal. And it's just going to be dependent upon that little dimension triangle, which is just the slope. And anytime you have a 3, 4 of your legs, your hypotenuse side will always be 5. And if you weren't sure about that, you would just take 4 squared plus 3 squared, square root it, and you would get 5. And you can utilize that to get the components in the X and Y directions. So since the 50's component in the X will be going to the right, it'll be positive. And then I will take my force of 50, and then I need to get it into the X direction, which I'm always going to be dividing by the number that is the hypotenuse of my little triangle. And then the numerator of this little ratio right here, it will be the number that is parallel to the direction I'm looking at. Well, I'm looking at the X. The 4 is measuring in the X direction, so it'd be 4/5. The 3 kips per foot, vertical don't include it, BY vertical don't include it, AY vertical don't include it. And then lastly, we have this 20 kips up here with this little extension. It is acting to the right, so plus 20 kips, and that's all I have equal to 0. Well, A sub X is just going to be the 50 times 4/5 plus 20 added together, and that gives me exactly 60 kips. And it came out to be a positive number, so I know my assumed arrow direction of to the left was correct. Remember, this arrow right here is only valid for getting minuses and pluses in your equation. Once you have your equation set, this arrow really doesn't mean anything when you get a final answer. If it is positive, that means you assume the correct direction. If it comes out negative, that means you assume the wrong direction. So keep that in mind when you're moving forward. All right, so now we have A sub X. So we just need A sub Y and B sub Y. Well, if we were to sum forces in the Y direction next, well, we would have two unknowns. Can't do that. So let's go to our moment equation, which is typically where you would go to right away. Or if you have an X reaction like we just did, we solved for it. So summing moments, and let's just sum about one of our reaction points so it drops out. So summing about point A. All the moments have to be in equilibrium about point A. So A sub X and A sub Y go right through point A. Don't include it. The horizontal of the 50 technically goes right through A, so we're not going to include it because technically it's going to act like right there. So we're just going to include the vertical portion, which would be 50 kips times 3/5, and that is my force. And then I need a distance to A, which is 12 feet. And this will be rotating clockwise about point A, so that is negative based upon my sign convention. And then I have this 3 kips per foot. You need to multiply by the distance it spans, which is 15 feet. And then you need to multiply by the distance from its centroid to where point A is. Well, just think of this like a rectangle. Its center is right there. It's going to be 15.5 from each end. So this total distance over here to point A will be 12 plus 10, which is 22, plus the 15 over 2. And that is my distance to get it to point A. It will also be rotating clockwise about point A, so that is negative. And then I have b sub y, I assumed it upwards, so that will be rotating counterclockwise, so it's positive, times its total distance to A, which is 37 feet. And then lastly, don't forget about this pesky little 20 kips up here at the top. Well, it will be rotating clockwise about point A, and its total vertical distance to drop it down to be in line with point A is 10 feet. So it'll be minus 20 kips times 10 feet. All of that must be equal to 0. Well, we can just rearrange, basically just take b to the opposite side and then divide everything by a negative 37 to get rid of that negative sign, of course. So then b sub y will pop out to be 51.01 kips. It came out to be a positive number, so that means my original arrow direction that I assumed of upward is the correct one. If it would have come out as negative 51, that means that I assumed the wrong direction and is in fact going downward. All right, so we've used the x, we used the moment. Now let's use our last one of Fy to get our a sub y. So taking up forces as positive in the y direction, I have ay assumed upward, so it's positive. The 50 kips portion will be going downward. And to get it into the vertical direction, it'll be multiplied by 3/5. And then we have the uniform load. It will be going downward, so it's minus 3 kips per foot times the distance it runs, which is 15 feet. And then we have b sub y. It is upward at 51.01 kips. And then the 20 is horizontal, so don't include it. So that's all that I have equal to 0. Keep in mind when you're working with uniform, triangle, or trapezoidal loads, you always have to take the uniform load or whatever the area of that loading is. So essentially for a rectangle, we're going to take the 3 kips per foot times the distance it runs. And the area of that load is how much load it's actually exerting on the beam. So that's why we're taking 3 times 15. Well, once you figure this out, a sub y is our only unknown there, and it pops out to be 23.99 kips, essentially 24 in the upward direction because it came out to be a positive number. So my assumed arrow direction of up is correct. So that's how you would find your reactions for a sub x, by, and a sub y for this particular beam. Now, whenever you're doing beam reactions, there is always a way to check your answers. And the best way to check your answers is just to sum moments about the point or the other reaction you did not sum about. So we originally summed about point A over here. So now let's sum about point B and see if we can get everything equal to 0. So summing moments about point B, we'll take counterclockwise as positive. Of course, this will be our check. Equal to 0. So I have a sub y up first. So it's going to be 23.99 kips times its distance to B, which is 37 feet. It will be rotating clockwise about point B. So it'll be negative. And then I will have the vertical portion of the 50. So it will be rotating counterclockwise about point B. So that'll be positive 50 times 3/5 in the vertical direction. Its distance to B will be 25 feet. And then I will have the uniform load. But once again, a sub x and the horizontal for the 50, they technically go right through B. So do not include them. So then we have our 3 kips per foot times the distance that it runs, which is 15 feet. And then we need a distance to get it over to point B, which would just be 15 over 2 to get to that center of that rectangle. So 15 over 2, so 7.5 feet. It will be rotating counterclockwise about point B, so it is positive. And then lastly, if I scroll up just a little bit here, don't forget about that pesky 20 there at the top. It is still rotating clockwise about point B. So it will be negative 20 times 10 feet. And of course, we do not include by because by goes right through point B. So does this equal to 0? Well, it's pretty darn close. It equals negative 0.13. And the reason why that it did not equal out to be 0 is simply because the 51.01 and the 23.99 are rounded off answers. If we were to take these exactly out as they are, then this would be exactly close to, or be exactly 0. But a good way to make sure that if this does not equal 0, how far off are you? Just take that number and divide it by the reaction that you used inside of that equation. And you will see that you get a very, very small number, which just means it's a very, very small distance or a very small percentage off. So that's how far off you are. And that is close enough. As long as this is not a good portion of your reaction value, you're okay. It's just rounding. So I hope this video was helpful. And if you want to see more problem solving this variety, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does help us out. Thank you for watching, and I hope you have a great day.